Hey guys, quick video about how to recognize when to use Pythagorean identities, reciprocal identities, and converting to sine and cosine. So a couple of examples here. One of them, number 2 from the homework, secant squared times 1 minus cosine squared equals tangent squared. Hopefully this one you would immediately recognize as a Pythagorean identity. So anytime you've got 1 minus cosine, 1 minus something squared, 1 plus something squared, really any two terms that are squared and are separated by a plus or minus, you should be thinking Pythagorean identities. Now, you do have to be careful though. Not all of them are going to work as a Pythagorean identity, and there's a few of those kind of mixed in there. So like, for instance, if this were a 1 plus cosine squared, you might think that that's a Pythagorean identity, but if you check sine squared plus cosine squared equals 1, to get the 1 and the cosine together, I have to subtract the cosine squared from both sides. So that doesn't work. That's not a Pythagorean identity. It only works if it's this. So in that case, I would start this problem by doing secant squared and converting this to sine squared, and then progressing further from there. All right, for reciprocal and converting to sine cosine, I want to take a look at number 4. So that is cosecant minus cosine cotangent is equal to sine. I'm not going to do this one all the way through either. I just want to kind of help get you started on it. Looking at this, right off the bat, I'm thinking that I want to convert everything to sine and cosine, and here's why. I've got cosecant, cotangent, cosine, sine. There's just a lot of things in there. If you ever have like 3 or more different trig ratios in one of these problems. Also, if you have 2 of them that aren't necessarily related by a Pythagorean identity, it's probably a good idea to start this by converting everything to sine and cosine. And so, for instance, this, you're actually going to use the reciprocal identity. Most of these reciprocal identities are going to essentially be converting to sine and cosine. So this one would go to 1 over sine. This one would stay cosine, but cotangent, it's cosine sine, equivalent is cosine over sine. And now you have 2 terms that have a common denominator. Everything's in terms of sine and cosine, and you could proceed from there, and it should work out.